6 is on slope fields and differential equations. So a differential equation is an equation that contains an unknown function and one or more of its derivatives. So we've dealt with these before. So we've done a little bit of this before. It's basically when you have like a y prime and a y in the same equation, and you have to like solve for, well, we've done the ones where we have y prime and we have to go backwards and solve for y. Okay, but now we're going to have things where we have maybe a y prime and a y in the same equation. So sometimes a very easy free response question, part A, will say something like, show that this is true, show that this works. So here's an example of one like that. So it says, show that this is a solution to the differential equation. So notice how in this equation we have both a y prime and we have a y. Okay, so that's kind of weird. That's what a differential equation is going to look like. All right, so if I want to find y prime, I just take the derivative. So I get 1, and then I have plus x to the negative 2, which is really 1 plus 1 over x squared, if you want to write it that way. So I want to show that it works in this differential equation, meaning that this creates a true statement when we plug it in. So I'm going to have x, and then y prime is going to be 1 plus 1 over x squared plus y, and I want to see if that's equal to 2x. I'm going to put a little question mark above it. Okay, so I start to multiply in, and I have x plus x over x squared is 1 over x. And then I have plus y. Okay, but what y is x minus 1 over x, right? So does it work out? Yeah, the 1 over x and then minus 1 over x go away, so we get 2x equals 2x. So it is a solution to the differential equation. Okay, it may not be the only solution, but it is a solution. All right, so it says, unfortunately, if you have a differential equation, it's often very, very difficult to solve for y. There are whole branches of mathematics that are devoted to this. So like when I was in grad school, I had friends that were in, you know, differential geometry or linear algebra or whatever. Well, I also had friends that were in ordinary differential equations and partial differential equations. Okay, so differential equations breaks into lots of different things. And you can spend a lot of time trying to solve these by hand, or you can use computers and so on. So we're going to talk about this. So it says, however, we can learn a lot about the solution with graphs called slope fields or direction fields. So I'm going to show you how we can even use Grapher to help us try to guess at what the equation is. All right, so let's do a couple of these by hand, and then I'll show you with Grapher what you can do. So on the AP test, you're going to have these little things that have dots. Did you guys see these graphs down here that have these little dots? And we're going to draw the slope at each of those dots. Okay, so it's going to be kind of weird. So it says, sketch a direction field to find the solution to y prime, which is equal to x plus y, and y of 0 equals 1. Okay, so direction field, you might also see slope field. That's another way to phrase it. And then this y of 0 equals 1, that's what we call the initial condition. Okay, so there's going to be a lot of different curves that will go through the slope field. But maybe there's only, well, there is only one that's going to go through that initial condition, okay? So it's not very hard. It's like graphing slope in Algebra 1. Okay, so if you have the slope is equal to x plus y. Okay, at the point negative 2 comma 0, what would your slope be then? Negative 2. You just add your x and y together. Okay, so that's for this equation. It's not always just adding the x and y together. All right, so the next one is negative 1, and then 0, 1. So you're just adding your x's and y's together. So just do it really quickly. So we find all those slopes. Okay, and then we're going to draw a little tiny segment at each of those slopes. So for instance, let me kind of sketch it down here. If I wanted a slope of 1, it's pretty easy. I think about going, you know, 1 unit to the right, 1 unit up. Oops, it still didn't draw it right. So I would kind of draw my slope like that. If I wanted a slope of 2, then I would think about going 2 units up, right? It'd be a little bit more steep. Does that make sense? So we're going to be using that as we're doing these. So think about where it's pointing to. All right, so if I have the point negative 2 comma 0, so that's right here. And I want my slope to be negative 2. It's kind of misleading because these are actually negative 1. It'd be pointing way down here. So my slope of negative 2 is going to look something like that. At negative 1 comma 0, so right here, I'm going to have a slope that's not as steep as that. so it's -1. And then at 0, 0, I have a slope of 0, which is just a horizontal line. And then at 1, 0, I have a slope of 1. And then at 2, 0, I have a slope of 2. So it's a little bit more steep. Do you guys see what we're doing? We're just drawing little tiny marks. Okay, now we're on to the next row. So -2, 1 gives a slope of -1. So kind of make it the same. These two are the same slope. Do you guys see they were both -1? All right, and then -1, 0 is, or -1, 1 gives you a slope of 0. And then 0, 1 gives a slope of 1. And then 2. And then 3. So get even more steep. It's really hard when you have like slopes of 4, 5, 6. It's like hard to draw. All right, and then the next one. So if I have -3, so at -2, -1, I have a slope of -3. And then I have a slope of -2, so not as steep. And then I have a slope of 1, or -1. And then 0 and 1. Okay, so that's called a slope field or direction field. Okay, and it would fill the whole, like you'd have these little tick marks everywhere. Okay, it creates kind of, it looks like a magnetic field. Have you guys seen magnetic fields before? It kind of looks like that. Like there's all these little marks everywhere. All right, so when it says sketch in the initial condition, this is something that you actually don't have to do on the AP test. The AP test, you have to draw all these little marks. And the way that they grade it is they're going to look at the different ones that should be positive slopes, and they're going to look at the negative slopes, and they're going to look at the zeros. Okay, and then they're going to look at two positive slopes and compare them. So they're going to be like, this one was a slope of 1, and this one a slope of 2. Is it a little bit steeper? But they're not going to be super, super picky. Okay, they're not going to like really take a ruler and check that your slope is perfectly at 2. Okay, but they will compare the positives and negatives and so on. All right, so the initial condition tells you the curve that goes through some of these tick marks. Okay, so if I'm at y of 0 equals 1, that's the point 0, 1. So the point 0, 1 is right here. So we're saying at that point we have a slope of 1. So it's going to have like a curve like that. And then you kind of like look at your other marks and you would realize that it kind of curves. It curves along those slope fields. So it's going to do like a little curve. And that's the part that I think high school students have a hard time with. Like you don't understand where it's going to go. Okay. And it's hard. But there would be lots of other curves. So don't draw these in, but like this would be an example of a curve. Or this would be an example of a curve. But they don't have that same initial condition. Okay. Those are different solution curves to the differential equation. All right. So number 2, so it says sketch the slope field for the differential equation that passes through the point 1, 0. All right, so it's the same thing, but now it's a little bit hard. So our differential equation is y prime equals y minus 2x. You can't just add your x and y together like that last one. It takes a little bit more brain power. I was struggling first period. Let's see if we can do it. All right, so y minus 2x. So I'm going to have 0 minus 2 times -2. So I'm going to get 4. 0 minus 2 times -1 gives me 2. Then I have 0, -2, -4. All right, then we do the next ones. So 1 minus 2 times -2. So I get 5. 1 minus 2 times -2, 3. 1, -1, -3. All right, and the next one, I have -1 minus 2 times -2. So I have -1 plus 4, so I get 3. -1 plus 2 is 1. -1 plus 0 is -1. -1 minus 2 is -3. And -1 minus 4 is -5. So we have all those points. And then we draw on their slopes with each of them. So if you have -2, 0, so we're over here on the left, we have a slope of 4, so make it kind of steep. -1, 0, we have a slope of 2, not as steep. 0, 0, slope of 0. 1, 0, slope of -2. 2, 0, slope of -4. I'll make that a little bit more steep. All right, then I have -2, 1 is a slope of 5. That's even more steep. That's where it gets really weird. Oops, up above. Sorry, that's this one. There. All right, and then negative 1, 1, I have 3. And then 0, 1, I have 1. And then 1, 1, I have negative 1. And then 2, 1, I have negative 3. Okay. So I know it's hard. Some of you guys are like second guessing your slopes and stuff. It's fine. Okay, then I have negative 2, negative 1 is 3. And then 1, negative 1, negative 3, negative 5. So something like that. So this one goes through the point 1, 0. That's still an initial condition. It's written a little bit differently. So it has to go through that point. So can you guys kind of tell where it would go? It's going to go like between those. It's going to go up, but at some point it has to turn because of that one slope that's positive. So something like that. All right, so it's always hard drawing in the solution curve. It makes more sense when we do it on Grapher. So this is an example. So it says you can check your solutions with Grapher. So if you go to equation, new equation from template, and so on, I give you all the directions. This is what's graphed there. So this is our second answer. This is that one, this one. Okay, so I went ahead and I sketched in the slope field, the little direction field. And then I I drew in the initial condition curve. Okay, so if you go here, I'll show you how to do it. So you go to equation, you do new equation from template, vector field, explicit. If you just put a 1 in the top, oops, maybe. And then what was ours? Y minus 2x. We put that in. Hit enter. It draws that direction field. Okay, so see how I said there's a whole bunch of those little tick marks? We only did some of them. Makes more sense when there's a lot of them. So can you guys see like different possibilities for curves when you see it this way? Like you have lots of different curves that you could have. Yeah. All right, and then we do equation, new equation from template, and now we go to differential equation, and we would do, whoops, I did second order. Second order means second derivative. I need to do first order implicit. I hit the wrong thing. So new equation from template, first order implicit. There we go. Get rid of that one. Okay. All right, so when I click on this one, I want to put in that y minus 2x for the first thing. Whoops, oh gosh, I'm really just messing this up. Y minus 2x, comma, and then y of, what was it, y of 0 equals 1 or y of 1 equals 0? Which one was it? Y of 1 equals 0. So I put that in, and then it draws in that curve. Okay, and if you look, I mean, I had kind of like a downwards parabola type shape. It's not exactly a parabola. It's probably like some kind of exponential function. It looks like that. Okay? So if I wanted to do the first one, I would just adjust, and I'd say, okay, well, this is going to be x plus y now. So it clearly doesn't match up with the curve, right? This is for the other equation still. So x plus y, and then this one was the y of 0 equals 1. Oops, y of 0 equals 1. Like that. Does it make sense? So it draws in that curve. Okay, so you can kind of check with Grapher if you aren't sure if your solution curve is correct. But like I said, on the AP test, you don't even need the solution curve. So you're really just drawing the little tick marks, and that's it on the AP test. And doing more, like calculus type stuff. All right, so the next thing. So it says, find the particular solution to the differential equation with the given initial condition. So 1A. So here's what you're going to do. So a lot of times part A will be sketching a slope field for these different points. And they'll give you like a little t-table and you're filling in. All right, this one, when it's part B, is always going to say, like, find the particular solution. So it's saying solve for y. With the initial condition, so through a certain point. Okay, and we do this by separating our variables. So that's what it says on this other page. It says, you're going to need to know how to do separable differential equations. These are the most basic differential equations you have. So it allows you to separate x's with the dx's, separate y's with the dy. Okay, so you're going to get like x's, all x's on one side, all y's on one side. So when I look at this, y prime is really dy over dx. Okay, so that's what we're going to write it as, dy over dx. Okay, and we're going to try to get the x's together and the y's together. So what we're going to do is we're going to take this dx, and it's a little bit weird, but we're going to multiply it over. Okay? And it's going to go with the sine of x. So I'm going to have sine of x dx. And then that y squared is going to go on the other side with the y, the dy. So do I just write y squared? No, it's 1 over y squared, right? Okay, we have now separated the variables. This is a crucial step on the AP test. If you do not do this, like this part is usually worth 5 or 6 points, you get 0 points. Okay, so of the whole free response question that's worth 9 points, you would miss 5 or 6 points here if you did not do that. Okay, this is always one of the 6 free response questions. They always have a differential equation one. All right, so now we integrate. Okay, so it's like, well, why are we integrating? Because we have a y prime equation and we want to find a y equation. Okay, we want to go backwards and find the antiderivative. So I'm going to rewrite this as y to the negative 2 dy before I integrate, just so it's easier. So I add 1 to the power, so I get y to the negative 1. I have 1 over the new power out front. Usually I do a plus c, but I'm just going to do it on the right side only. Okay, so I'm going to have negative cosine of x plus c. So you can just pick one of the sides. It doesn't matter which side. It's just like if I had like f of x plus 5 and I had g of x minus 6, I could have written g of x minus 11. Do you guys see? And had the f of x with nothing over there. Okay, you're still just adding a constant. I just added it only to one side. If you really want to do C1 and C2, you could, I guess, but it seems complicated. All right, once you've done this, okay, this isn't your answer, but you've now found C, or you have C written. You want to find C at this point, using that point that was given as your initial condition. So using this, y of pi equals 1/2. So it's saying plug in pi for x and get a y value of 1/2. So that's what we're going to do. So I'm going to have negative 1 over y. Let me write that first so you guys can see. Make sure it's as clear as possible on your notes. So we're plugging in pi comma 1/2 to find c. So I have negative 1 over 1/2 equals negative cosine of pi plus c, like that. So negative 1 over 1/2 is negative 2. What's negative cosine of pi? It's negative times negative 1, right? So it's going to be 1. Subtract the 1 over, so I get negative 3 equals c. All right, and we plug that in. So we go back to this point where we had everything like plus c, you know, and we plug in. So we're like, okay, I have negative 1 over y equals negative cosine of x minus 3. And we have to solve for y. Okay, so if we're solving for y, I'm going to first multiply by a negative 1 on both sides just because I don't like all those negatives. So I get 1 over y equals cosine of x plus 3. Any ideas? How do I solve for y? You can multiply the y over and divide by the whole cosine of x plus 3. Or if you ever have that, if you have like 1 over x equals 3 over 2, what could you do to both sides? You just flip it. X would be 2/3, right? That's what we're going to do here. Whenever you get like 1 over y, we flip it. So we say y equals 1 over cosine of x plus 3, like that. All right, and we're good. That's our answer. All right, now the next one, I think, this is really hard to integrate. I think I meant for this to be an R and this to be a U. We'll skip it for now, though. So I'm going to skip it. We'll go back to it maybe tomorrow. But I made it very difficult. So let's do more than one that's more Calc 1-like. All right, so dy over dx equals y over the square root of x. It was basically one where you couldn't solve for y. You couldn't get y by itself. But on the AP test, you're always going to have to get y by itself. All right, so here we go. So we're going to separate our variables. So think about how to separate our x's and our y's. We never want a dx on the denominator. We never want a dy on the denominator, okay? So that means that I'm going to have the dx over here and the dy here. So on the right-hand side, I'm going to have 1 over root x. And on the left-hand side, I'm going to have 1 over y. Do you guys see how I'm doing that? You can do a bunch of steps in between, like cross-multiplying, dividing over. I mean, you can do all that. Do you guys understand that? Yes? Okay. So I'm going to write this as x to the negative 1/2. So I have x to the negative 1/2 that I'm integrating. Gosh, I still can't get that stem there. And then I'm going to leave this one as 1 over y because do you guys remember how to integrate 1 over y? Yeah. So natural log of the absolute value of y. Okay, I'm not going to do the plus c on that side. I'll do it on the other side. So I'm going to get 2x to the 1/2 plus c and the natural log of the absolute value of y. Don't forget the absolute value. Very important. Okay. So this is the point where we have a c in our equation. As soon as you have that c, find what c is. You don't have to. You could do a bunch of work to solve for y, but it's going to get really complicated. It's easier if you just find c now. Okay, so if you find c, this is the point, 9 for x, 1 for y, right? That's our point. So we're going to plug in 1 for y and 9 for x. Like that. And we're going to solve. And all of you guys should be able to do this in your head. So 9 to the 1/2 is what? 3. So you have 2 times 3 is 6. What's natural log of 1? 0. So you get c is equal to negative 6. Once you have that, you plug back in. So you say, okay, I have natural log of the absolute value of y equals 2x to the 1/2 minus 6. Okay. How do you solve for y? What exponent? Yeah, you're going to do e to both sides. Do you guys remember that? If you want to get rid of the natural log, you could do e raised to both sides. Or you could switch forms like it's log base e, so e raised to the other side. So you end up getting absolute value of y equals e to the 2x to the 1/2. So I'm going to write 2 square root of x minus 6. All right, and then what about the absolute value? How do I get rid of an absolute value? Anybody know that one? Yeah, you do a plus or minus. Yep, so it's going to be y equals plus or minus e to the 2 root x minus 6. Now here's the weird part. So, I went to grad school for math. I did a lot of differential equations. I like differential equations, okay? But a lot of Calc 1 teachers never did differential equations because it actually wasn't required when we were in AP Calc. Okay, so it started being required like 2003 or something. So a lot of Calc teachers, and this is always something we talk about in these conferences that I go to, all right, they have no idea why this is true. And the books don't talk about it either. Like the Calc 1 books just totally go over it, skip over it. But the AP test now has started grading this, okay? And this has always shown up on the last 3 years worth of AP exams. Okay, so do you guys know how I had this curve drawn in? There's always just one curve. There is never a skip. It never is I'm going to go this way for a bit, and then I'm going to skip over to here and then draw the rest of the curve. It never is, it's always a continuous function. Do you guys see what I'm saying? There's never two pieces to it. Okay, we call this a branch. So this is one branch. It's a continuous branch. Okay, so when you say something like plus or minus, that is bad. Okay, because that is two solution curves, and we should have one unique curve. Do you guys get that? This is where you go back and you think about the point. If you plug in 9, you want to get positive 1. So which one do we circle? The positive one, right? You can't have plus or minus 1. You only get 1 out. So we want the point. Sometimes the AP test, sometimes the tests make it 9, negative 1, and then I wrote that. So sometimes the tests make it 9, negative 1, okay? Be looking for that. They try to trick you. I've told you this before. So look for that. We want the 0.91. So our solution needs to be e to the 2 root x minus 6. And they need to see that you've made that decision. Okay, so I would write plus or minus, and then on the next line I would write which one it is. Okay, other things that they're going to do. Okay, you might see this written as e to the 2 root x and then e to the negative 6. So they might have something funky like, I don't know, like e to the 6, like that. They could do that, but this is usually on the free response, so it's not usually like a big deal, okay? So I wouldn't worry about it. It could be like a multiple choice type of question, or they might just put a constant, and then e to the 2 root x, right? Because that e to the 6th was a constant, e to the negative 6. Okay, anyway, and then the last thing I want to mention is you still have to talk about restrictions to your domain and or range. Okay, so if you ever have a natural log, so if you have, oops, I can't write. If you have ln, a denominator, a square root, etc., write the restriction. Okay, so it's not super important for the y value, but it will be for the x value. But let's go ahead and do it for y anyway. So when we have this, natural log of the absolute value of y, there's one number that you are not allowed to plug in for y. What can you not plug in? 0. Can you plug in a negative 1?
Yeah.
Yeah, why? Because there's absolute values, but you cannot plug in 0. Okay, that creates the 2 branch thing again. Do you guys see what I'm saying? Like the fact that there's a 0 that's undefined. Okay, it's creating that 2 branch thing. So I would just very tiny, I would write y is greater than 0 in that case, because your y value is 1, right? So y has to be bigger than 0. You're choosing one side. You're choosing, is y bigger than 0 or is y less than 0? Is there anything else that would create a domain issue? 1 over what?
Root x.
1 over root x, right. 1 over root x. Is x greater than 0 or less than 0? Greater than 0. Do you guys see it right here? There's still a root x in your answer, isn't there? So I would just write x is greater than 0. Would you say greater than or equal to? No, I would just say greater than, because at this point it was on the bottom, right? So I would say greater than or greater than 0. Just leave it like that. Okay, so there's lots of weird, like tiny things, and they're only tiny little points. But when it's out of 9, if you're missing 1 point because you didn't write this, I mean, that's a bummer. You're getting 8 out of 9 when you could, 88%, right? When you could have gotten 100%. All right, so next one, so D. So again, we're going to try to separate our variables. So we're going to have, running out of room. So I'm going to have, this is the dy over dx, right? It's on the right-hand side now. So I'm going to have 2y plus e to the 3y dy equals cosine of x dx. Okay, so remember, you have to show that step where you separate the variables. And then we integrate. So if I integrate cosine of x, I get sine of x. So I'm going to do plus c on that side. I usually do it with the x's. And then the y's, I get y squared plus, do you guys know this one?
1/3.
1/3 e to the 3y. It would be like a little u substitution, right? This is one where you're not going to be able to solve for y. Do you guys see how you won't be able to get y by itself? All right, so we have the point y of 0 equals 0. So I'm going to plug that in. So I have sine of 0 plus c equals 0 squared plus 1/3 e to the 0. Well, e to the 0 is 1, so I still have a 1/3. Sine of 0 is 0, so I get c equals 1/3. So in this case, all you would be able to do is plug in. So you'd have sine of x plus 1/3 equals y squared plus 1/3 e to the 3y. And that would be your answer. Okay. The AP test will not make that one of them. It's always going to be something in solve for y. All right, so this one. So solve for y if dy over dx equals y over root x minus 3 if y equals 1 when x equals 3. So you're going to have 1 over root x minus 3 dx And you're going to have 1 over y dy. So you want to separate so that the dx and the dy's are on the top. You never put them on the bottom. Like a lot of people think it would be easier. They're like, oh, well, why don't we just do square root of x minus 3 dy equals y dx? Because you need x's by themselves and y's by themselves, right? All right, integrate. On the right-hand side, it involves a u substitution. So we get 1 over square root of u, so u to the 1/2. Let me write it as u to the negative 1/2, the whole thing. So u to the negative 1/2 du. And then when I integrate the left-hand side, I actually have the natural log of the absolute value of u, right? Or y, I mean. So I'm going to get natural log of the absolute value of y equals 2u to the 1/2 plus c, like that. It's like almost exactly the same as what we had here on part C. But our u is really x minus 3, right? So plug that back in. Because we want y equals 1 when x equals 3. So when x equals 3, we get 2 times 0 plus c. And then we have natural log of the absolute value of 1. We always like natural log of 1. Goes away. So I get 0 equals 2 times 0 plus c, so c equals 0. So we're going to have natural log of the absolute value of y equals 2 times the square root of x minus 3. I'll write it that way. So we have the absolute value of y equals e to the 2 root x minus 3. And then we choose our plus or minus. Yeah, we want to be able to plug in 3 and get positive 1 out. So that should be plus. So it's going to be y equals e to the 2 root x minus 3, like that. Lovely. Yeah, you would need to write somewhere x is greater than 3. Can x equal 3? No. All right, so there's lots of weird things that are going to happen on these. So we'll be doing a lot of these over the next couple days. They're super important, so we need to spend a lot of time on them for sure.